Hey guys, welcome back to All About AI Tech tonight. We're diving deep into a game-changing technology that's reshaping the world of robotics, Sim2Real. Imagine a world where robots can learn complex tasks in a virtual environment, a safe space where they can practice and make mistakes without causing real-world damage. That's the power of Sim2Real. It's like a training ground for robots, a digital dojo where they hone their skills before stepping into our physical world. This approach is not just about making cool videos of robots doing backflips in a simulation. It's about making robots more useful, more adaptable, and more affordable. It's a critical step towards bringing advanced robotics into our homes, workplaces, and even into challenging environments like disaster zones. Sim2Real isn't without its hurdles. Bringing those virtual skills into the real world is tough. It's like trying to perfect a recipe in a test kitchen and then expecting it to work flawlessly in a busy restaurant. There are just so many variables. The lighting might be different, the ingredients might vary slightly, and there's the added pressure of a live audience. Similarly, the real world throws curveballs at robots that they might not have encountered in the simulation. Surfaces might be more slippery, objects might be different shapes and sizes, or unexpected obstacles might appear out of nowhere. This difference between the simulated world and the real world is what we call the Sim2Real gap, and closing this gap is the holy grail of robotics research. NVIDIA, the powerhouse of graphics processing, has stepped onto the robotics field with their impressive Isaac platform. Isaac isn't just your average software. It helps robots learn more effectively and prepares them for the real world. It's like giving them a specialized education tailored for their future jobs. NVIDIA has figured out that robots need three main computers, so to speak, to really excel. The first is for training their AI. The second is for virtual practice and digital twins of the real world, using platforms like Omniverse. And the third is a powerful edge AI. NVIDIA's Omniverse is a game-changer for creating realistic virtual environments. It's like a Hollywood studio for robots, allowing developers to build detailed digital twins of factories, warehouses, or even entire cities. These virtual worlds aren't just visually impressive, they accurately simulate physics too, ensuring that robots learn to interact with their environment in a realistic manner. Think of it as a virtual playground where robots can master the art of picking up objects, navigating obstacles, or working alongside humans before ever setting foot in the real world. This dramatically reduces the need for expensive and time-consuming real-world testing, making robot development significantly more efficient. The geniuses over at MIT are tackling the Sim2Real challenge with a brilliant system called Lucid Sim. Lucid Sim is like giving robots a vivid dream world where they learn by experiencing different scenarios. It uses generative AI and physics simulators to create these virtual training grounds, which are both realistic and diverse. The really impressive part? These robots are achieving expert-level performance without ever seeing the real world during training. The implications are massive. Imagine training robots for complex tasks like search and rescue missions or exploring other planets, all within the safety of a computer simulation. Ambi Robotics is a startup making serious waves in the logistics industry with their Ambi Sort system. Ambi Sort is like a super-efficient postal worker, able to sort packages with incredible speed and accuracy. What's their secret weapon? Sim2Real AI. They train their robots in a virtual world, speeding up the learning process by a factor of 10,000. AmbiSort not only solves the problem of labor shortages in warehouses, but also empowers human workers by automating mundane tasks and allowing them to focus on more complex and fulfilling roles. It's a win-win situation for businesses and employees alike. Figure AI is pushing the boundaries of humanoid robotics with their ambitious goal of creating commercially viable, general-purpose humanoids. Their latest creation, Figure 02, is a sleek and sophisticated robot designed to be a true partner to humans in the workplace. Figure 02 learns through embodied AI, experiencing the world much like we do, and it even has speech-to-speech reasoning capabilities. The potential applications are breathtaking, from warehouse logistics and manufacturing to even assist in healthcare and eventually space exploration. Imagine having a robot capable of understanding and performing complex tasks, communicating effectively, and working seamlessly alongside you. That's the vision Figure AI is bringing to life. Agility Robotics has addressed the Sim2Real gap with their remarkable humanoid robot, Digit. Digit is designed for logistics work, and it's already being tested and used by industry giants like Amazon. What sets Digit apart is its ability to work in unstructured environments, adapting to real-world challenges like uneven surfaces and unexpected obstacles. This real-world competence is made possible by a combination of sophisticated model-based control and inverse dynamics. It's like Digit has an internal physics engine that calculates and adjusts for every movement, giving it the agility and balance it needs to navigate our world. Imagine teaching a robot to perform complex tasks like making breakfast, not just by showing it once, but by giving it a rich understanding of the world and the tasks themselves. This is the goal of robot foundation models. They provide a powerful base of knowledge and skills that robots can then apply to solve a variety of problems. This approach is like giving robots a comprehensive education instead of just teaching them specific tasks. It fosters adaptability and opens up new possibilities for creating robots capable of performing well in various settings. Generative AI is not just about creating cool art and chatbots, it's also transforming robotics. Lucid Sim, the MIT system I mentioned earlier, is a great example of this. It allows researchers to create realistic simulated environments and generate dreams for robots by creating short videos from a robot's perspective, showing how it would move through an environment. Imagine this. Now we can give robots practice without the risks. We can create endless virtual variations of our real world, letting them safely learn and adapt before taking on physical environments. Physics-based simulation is not just a cool technical term. It's the key to making Sim2Real simulations effective. This means creating virtual worlds that obey the laws of physics, just like our real world. This is critical for robots to learn how their actions impact their environment. If a robot pushes a virtual object, it should react realistically according to its weight, shape, and material properties. This level of accuracy in simulation allows for meaningful training and gives us confidence that skills learned in the virtual world will translate to the physical one. Sim2Real is playing a critical role in the development of self-driving cars. It's helping researchers train autonomous vehicles in simulations that accurately reproduce real-world road conditions, traffic patterns, and even pedestrian appearances. This is much safer and more efficient than testing on real roads, especially when teaching cars to handle challenging scenarios like sudden lane changes or unexpected obstacles. Think about it. With Sim2Real, we can test autonomous vehicles for millions of virtual miles before they ever hit the pavement. As we develop more advanced robots and AI systems, ethical considerations are paramount. It's our responsibility to make sure these technologies are used for good, not for harm. We must consider the potential impact of robots on employment, privacy, and even human safety. As these technologies become more integrated into our lives, it's essential to have open discussions about their ethical implications and develop guidelines that ensure responsible development and deployment. We must prioritize human well-being and ensure that AI and robots remain tools that empower us, not replace us. The future of robotics is bright, driven by Sim2Real training, better hardware, and breakthroughs in areas like AI and simulation. We're on the cusp of a robotics revolution where robots become integral to our daily lives, helping us with everything from mundane chores to solving complex scientific mysteries. As these technologies converge, we can expect smarter, more adaptive, and more versatile robots than ever before. This progress comes with responsibility, so together, we can shape a future where humans and robots coexist and collaborate, each contributing their unique strengths to build a better world.